Hi everyone. I thought we would try to do this quiz problem and maybe pay more attention about how to start off the problem because that's the hardest part. So if the concentration of methane, CH4, in Garwood Hall is this, what mass of methane in grams is present in a chemistry lab with these dimensions? Well, already by the time I got to the end of the problem, I forgot was at the beginning, so let's kind of dissect it. They're telling us the concentration of methane in Garwood Hall is this. Well, what does this mean? That means that for every 55.0 micrograms of methane, there is 1 cubic meter of what? Well, let's maybe picture this a little bit further. If this is Garwood Hall, and Garwood Hall is large, so this is Garwood Hall. For every 1 cubic meter, you can imagine a cubic meter, there's this many micrograms of methane. So what is this cubic meter? You can call it a couple of different things. I think I called it air, but you could call it space, you could call it building, you could call it Garwood Hall. But this really is a relationship between the mass of methane and the volume of air or space or whatever you called it. That's going to be an important relationship. That's a conversion factor. And it's really helpful to write down the item or the substance. Notice in the problem they just said micrograms per cubic meter, but I like to take the time to say, well, this is micrograms of methane for every cubic meter of air or space. So now I'm starting to get a feel for what this relationship means. So they want to know, given this relationship, what mass of methane in grams is present in a chemistry lab? So there's some lab here, and they're giving us the dimensions. So this is a lab in Garwood Hall. It's 18 feet by 25 feet by 12 feet. And they want to know how many grams of methane are in this volume of space or volume of air. So why don't we find the volume of this room? When I did it, I got 5.40 times 10 to the third feet times feet times feet, or cubic feet. And again, this is volume of air. So if you read that question again, what mass of methane in grams is present in this volume? So the question boils down to this many cubic feet of air equals how many grams of methane? So really they're asking us to convert from volume of air into mass of methane. This is the conversion that we're asked to do. And it's fine because we have a relationship between volume of air and mass of methane. If we want to use that relationship, though, we've got to convert our units for volume, which is in cubic feet, into cubic meters. So this is where we begin. And there's more than one way to convert from cubic feet of air into cubic meters of air, but I'm going to say that for every 3 feet, I have 1 yard, and I'm going to write down my stuff. It's air, but I don't have feet. I've got cubic feet, so cube the unit and the number downstairs, and the unit and the number upstairs. So cubic feet of air cancel. And then I'm thinking that there's this relationship here. So we could say that for every 1.0936 yards, there's 1 meter. And I'm going to write down my stuff. It's air, but I don't have yards. I've got cubic yards. So cube the unit and the number downstairs, and the unit, and the number upstairs. So cubic yards of air cancel. Now we're in a position where we can use this conversion factor. For every 1 cubic meter of air, there are 55.0 micrograms of methane. And we're almost there. They didn't want the units in micrograms, they wanted the units in grams. So one final step. 1 times 10 to the 6th micrograms of methane are in 1 gram of methane. And I think I'm going to need 3 sig figs in my answer. Let me do the arithmetic. I am getting, and maybe I'll put the answer here, 8.41 times 10 to the negative third grams of methane. So again, I think the way that we started this problem was really understanding what this relationship meant. It was a relationship between mass of methane and volume of air, or space if that's what you called it. And what did they give us? They gave us the volume of air and asked us to convert into mass of methane. So I hope that helps, and thanks for listening.